just want to explain this in the most simple way possible. So let's just solve each one of these problems as we go without any backstory, because it will get complicated really fast if you try to go into depth. Any of this stuff, basically what you really want to know for these first few problems is, what is a function? Is a relation given a certain set of points, for example, for this first problem? How do we know if it's a function? Well, the definition of a function, let's look at these points first. You're given the points 5, 4, you're given the point -2, 4, given the point 4, 3, and you're given the point 1, 0. Okay. What are these? What is this? This is in the form x, y. These are an ordered set of coordinates. Sort of like, if you know anything about latitude and longitude, you need to know, if you're only given the latitude of something on the globe, then you'll know, like if I say I'm at a latitude of 60, say this is the equator, and I look at like somewhere around 60 degrees, maybe that's up here, then if I'm just told my latitude, I could be anywhere along this spot on the globe. How do I actually find myself? Is if I'm also given a longitude. So if I then tell you my longitude is something, let's say this is the prime meridian, longitudinal line 0. Let's say that I'm to the west, like 10 degrees or something, then I know I'm going to be somewhere like right here. But I also know that I am at this latitude up here. Then I know exactly where I am. Given a latitude and longitude, all I need is 2 coordinate points, one to tell me where I am lengthwise, vertically, one to tell me where I am yeah. Anyway, graphing in an XY coordinate system is similar. We know that we are given the coordinates x, y, and we know that we have some axes, y in the vertical, and x in the horizontal, going to negative x over here, negative y over here. We know that where they cross, this is the origin, x, y is 0, 0 at the origin. Now, let's just graph these points, because we can. So first of all, we have a point at x equals 5, because look, these are all of our x's. These are all of our x values, and these are all of our y values. Okay, so we have a point at x equals 5. Let's draw this 1, 2, 3, 4, 5. So we also have a point at x, the corresponding y value for this. So again, just like we looked at before, could have had a given coordinate telling us the longitude, but if we didn't have the latitude, we could be anywhere on this line. So in this sense, the y value is going to tell us our latitude. The x value is going to tell us our longitude. I don't know if this analogy helps, but if you're used to reading maps, it should help. So, 1, 2, 3, 4, up our y-axis, and then we draw our line. Now, if we didn't have an x value, we could be anywhere along this line for all we know, if we're just given that y equals 4. But because we know that for this given point we have x equals 5, y equals 4, we know that only point that fulfills that, the only point that is this point right here, 5, 4. Great. It's just basics of graphing. You can graph these other ones pretty fast. If we look at the -2, just continue our axes this way, sorry. This is x equals -2. We know that somewhere along this line, we will have a y value corresponding to it, giving us a point, and that point would be y equals 4 as well, interestingly enough. Great. Now we have x equals 4, so at x equals 4, let's draw our line, or dashed line, and we know that this x equals 4 line corresponds to a y is equal to 3, which is 1, 2, 3. Let's draw that. Where does it meet up with x equals 4? Because that is the point. That is the point where this point is supposed to be graphed. Just erase this. This is the point. 4, 3. Okay? We'll label this point 2. This is the point. -2, 4. Okay. And now we have one last point. It's at the point x equals 1, y equals 0. Well, x equals 1 is right here. Y equals 0 is starting at 0. This is y equals 1, this is y equals -1, this is 0. So we have a point right at x equals 1, y equals 0. That's that point there. Okay, now what are we really being asked about these? We've graphed them, so great. It wasn't necessary to solve this problem to graph them. We didn't have to graph them, but we did. It's more to illustrate this thing called the vertical line test, which I'll show you in a minute, and it will be relevant to problem 2, so it's good to ahead of the game. So for what we have here, let's just connect our function. We know that this is going to do something like this, maybe it's not, but it could be something like that. And let's ask ourselves, is this a function? Now, there's a great way to tell, given a graph, if it's a function. And the reason we can do this is called a vertical line test, okay? We basically will draw vertical lines and we'll ask ourselves, does it pass through the graph of this? Does it pass through this relation more than once? Okay? And we can see what we mean by that by just showing you. Basically, if I were to draw a line here, did it pass through the function more than once? Well, where did it pass through the function? It passed through the function right there. And it only passed through once given that vertical line. It only passed through once given that vertical line. I could draw infinite vertical lines here, and trust me, it's only going to pass through the function once. What is this actually telling us? This is telling us in words that for any x value,